All right, so did everybody look up the atomic number was 28? All right, so the number of protons are 28. Is everybody okay with that? All right, so how many electrons are there, Alicia? Do you remember? Oh, you weren't here the day we did this. Jennifer, how many protons or electrons are there? For nickel.
Did you say electrons?
I said electrons.
Oh, yeah, 28.
28. All right, so the protons and the electrons are 28. So now that you thought I said neutrons, how many neutrons are there? All right, how do I find neutrons? Betsy Bay.
Oh.
Remember what we did to find neutrons?
Yeah.
What do we do?
It's the number. No, the mass minus the number.
There you go. So we take the mass and we subtract the number. So mass minus the number. So what's the mass? Subtract the number, which is? So what do we get when we say 60 minus 28? 32. Everybody okay with that? Okay. So in the second one, this one's called nuclear symbol notation, and both numbers are given to us. So how do I find the protons, Hyro? How do we find the protons? What's the atomic number? You can get to that one. All right, Salma, what's the atomic number? 33. So how many protons are there?
33.
Good. All right. How many electrons are there then, Hyro? There's what? Say it loud enough I can hear you. 33. If you were sitting up here talking to Brian or Liliana, I'd be able to hear you. So say your answer with some confidence. All right. So how do I find my neutrons, Brian?
Add the atomic number and the mass.
No. To find the neutrons, we do what? You subtract mass minus number. So we take our 78 minus 33, and what do we get when we say 78 minus 33? Huh? 45? Is that what you said? All right. So what's the mass and the charge on a neutron? Destiny, what's the mass on a neutron? You look it up in your notes? Huh? It is? All right, so the mass on a neutron is 1. What's the charge, Dylan? Yep. All right, so we want to write hyphen and nuclear symbol notation. So we got to go backwards. All right, so if we have 50 electrons, how many protons do we have, Eric? 50 protons. All right, so what tells us the element given that information? All right, anybody remember what told us the element given that information? Leandra, you remember? What number's at the top?
Huh?
What number's at the top? Okay, but I don't have an atomic number yet. Okay, there you go. So, because you know we have 50 protons, Leandra knows that's our atomic number. All right. So the atomic number tells us the what then? Tells us the what? You've already made a leap, which is what I'm trying to get you to tell me. That tells us the what? It tells us the element. See, Leandra's doing it in her head, and I'm trying to get her to say that out loud, okay? She knew the electrons and the protons told her the element, okay? So she's already got the periodic table in her hand trying to look up the element, all right, because she knew the protons were 50. That told her the atomic number, and so she's already scanning the periodic table looking for the element. So the protons are the atomic number is the element. Everybody got that? So what element did you find? 10. All right, so we're going to need it in this format and that format, okay? Now, we need both numbers. We need the mass and we need the atomic number. What's the atomic number? The 50. All right, the 50 is used in the one that has the symbol, but the mass gets used in the one that has the name and the one with the symbol. Now, a lot of you want to look up there on the table and just find the number on the table and write it in there. We don't do that, okay? This is why I told you on Friday I would talk about isotopes, but I was doomed to disappointment because y'all took the whole class time. And we're going to talk about that first today up there and talk about isotopes. However, We don't use the mass on the periodic table. You got to use the numbers in the question. What two particles make up a mass? What did we learn last week? What two particles make up a mass? Mass equals who? I heard two people say it out there. Protons and what? Neutrons. So, how many protons do I have? 50. And how many neutrons do I have?
70.
So, what does and mean in math class? So, 50 add 70 is what? So, I put hyphen 120. And in that one, I write 120. Questions? Anybody?
What if we just put 118?
I'd mark it wrong. Completely. Wrote 118. Mass isn't 118. It's 120. Any questions? That is an average on the periodic table.
So do we always round? Because like how you put 60?
The number on the periodic table is an average. We're going to talk about that. Okay? Hold that thought. All right, let me hand back your test papers because some of you want to see what you got right, wrong, and then we'll talk about your homework and where those numbers on the periodic table come from.
What's it?
Friday. I know, it's been 2 days and you forgot already. All right, Alicia didn't take it, so let me send her out. Bryce doesn't know enough to know anything we're talking about on the test, so we need to stay. All right, everybody else took the test. All right, Brian. Now, the very back page has the printout from the zip grade. It takes a picture of the test, and there are two columns that you'll see. PRI stands for the correct answer, which is the primary answer, and STU stands for student, and that's what you voted. All right, Sarah Elliott is our high score. She missed a grand total of one question. Tim's test is stuck somebody's here. We already had a whole bunch of stuff to the back.
Wait, y'all knew she told me.
And for
You want me to step out?
you to take it?
No.
Yep, you too. That's the. You're still stuck. Any other stuff? You might have had a bunch of paper stuff. Maybe yours too. So Gabriel's not here. Come out. Anything else not take it? Trent. Tim's not here. Can I give everybody else this paper? Except Bryce. But Bryce doesn't know anything. Dylan, did you not take it? You took it? Did I hand you one? Is anybody stuck to? Some of them felt thick. Check see if it's stuck. No, yours is stuck to the back of Tim's. I can see it through here. The staples are hung up. There it is. It's all too big. Stop worrying about it, Tim. All right, if there's something you're just dying to know, I'll be glad to answer it. Now, I think I told you this on Friday. I'm going to allow test corrections on the first test. I typically do. All right, so that means you can come and do test corrections and get half your points back. We're doing test corrections Tuesday, Wednesday, and Thursday of this week. All right. So if you would like to do test corrections, you may. I do not do test corrections on every test. Typically in an honors class, I do test corrections on 2 per quarter. Okay. So if you choose not to do any on this test, then you will be down to only 1 that you can get test corrections on. All right. So it's your option as to whether you do them. This is an easy test to do test corrections on. So you choose. Okay. We have a benchmark coming up. Typically, I count that benchmark, and I typically will do test corrections on it, which will be your 2 for the quarter. Okay. So keep that in mind. Okay. But it's your call as to whether or not you do test corrections. For respondents, never have test corrections, by the way. The next one will be half and half, and the 2 past that will all be for response. All right, is there anything you're just dying to know and have to have an answer to before you get the opportunity to do test corrections? Now, when you come to do test corrections, oh, y'all can't keep the test, so if you're like Jennifer, they're putting in your little thingies, stop, I'm taking them back up. Those you cannot keep for the very reason that Leandra mentioned the other day, with people giving away or whatnot their notes. These would be very hot items around the building. No, absolutely not. What was I getting ready to say? Go. I got nothing. It may come back, it may not. Any questions?
You just come back to school.
Tuesday, Wednesday, or Thursday? Oh, I don't know if this is what I was gonna say or not. You can use me when you come to do test corrections. You can use your notes, you can use a classmate. Okay, you do not have to sit silently at your desk and try to correct something you didn't know how to do the first time by yourself. Okay, so if a classmate's here, they know how to do it, want to explain it to you, they can. If you want, just need to look it up in your notes because you forgot it, you can do that too. And if you have absolutely no idea and you need my help, you can get my help too, okay? The idea behind test corrections is to learn how to do it correctly. Now, one of the things you do need to know is if you correct it on your paper and you don't show me how to do it correctly, am I giving you your points back? The answer is no, okay? Particularly if it's a math problem, you gotta demonstrate how to do it correctly to get your points. Particular form that you use, all right? I've probably seen it before if you had the formula because it's my form. All right? Looks like this. All right, I don't really care about the first three columns. It's just what number, what you marked, and what the right answer was. This third, fourth column is the important one. You show me your work or explain, okay? If the explanation or the work is not right, you don't get your points back. But again, you can use me if you don't know how to correct it, okay? You don't have to sit there and do it wrong. If you do the correction and you're like, I don't know if I'm gonna get any points back. What can you do? Ask. And I'll tell you if you're gonna get your points back before you even walk out the door. All right, if you come Tuesday, I'm going to probably have looked at it or graded it before you come back on Wednesday to class. And you can say, hey, that's all, I get all my points back. And if I go no, Thursday and fix them, the answer is yes, okay? So it's up to you. You choose. You're not required to do test corrections. It's just an opportunity off. Any questions? All right, I'm gonna have those back so that we can move on because we got a short class today. And I'd really like to make sure we can find protons, neutrons, and electrons before we leave class today. Did you give me 10?
Yeah. And I think for this one?
Otherwise, I will forget that there's somebody there when you don't like something. I've had a problem with that in the past. Yes.
The answer for number 7. That's not that.
All of the following measurements describe measurement standards except C. Yeah, it says that they don't have to agree with a previously defined size, and they do have to agree. Okay, like a foot, we all have to agree that a foot is 12 inches. Otherwise, we wouldn't be able to measure the distance from that wall to that wall and be able to replicate it for, building a house or something. All right, if you will, find your homework. Let's talk about that. All right, because some of you may have questions, some of you may not, but we need to at least make sure we can find mass and talk about those isotopes because I know that is a problem. Let me put these up, and again, tomorrow we'll do test corrections. Remember, those of you who haven't taken the test, if you wait till past Thursday, am I giving you a chance to do corrections? The answer is no. Hi, Rob. Tuesday, Wednesday, Thursday. All right. So let's look at what you came up with. Let me find mine. Rather than me just reading out these numbers across,
You put the homework up?
that's what I'm getting ready to do.
Ooh, so also, I have like a whole bunch of questions.
Okay. I'm going to put it up rather than me reading the numbers across, and then I'll answer questions.
Okay, so now I have a question. So do we, for the mass,
Mhm.
we don't put what's on the table?
That is exactly what we're getting ready to talk about. Yes. Yes.
Yeah, okay, yeah.
All right. There are the answers to the homework. All right. And I want to talk about that column that says maths.
Ooh, okay. Yeah, thank you. Thank you. Crazy.
Okay. Stop all that noise. Okay. So we make it bigger? I can make it bigger. And then I'll answer questions in just a second. That way, everybody's got a chance to check their answers. Is that any better? All right, can we talk about some answers? Everybody had a chance to check, or am I still waiting?
For Argon, all of these are rounded up.
We don't round. None of these are rounded. Okay? And we're going to talk about how to get mass. None of these are rounded,
It's time.
with the exception of looking up an atomic number on the periodic table. I did not use the atomic mass on the periodic table to do any of those questions. Okay? Which is where we're struggling on this piece of paper. Okay? Because you guys want to look up the atomic mass. I did not use the atomic mass to do any question on this table. All right, we have time to check them now. All right, so when we go to find, let's say, pick one that y'all had trouble and wanted to round up on. Use that argon? All right, when you look up argon and you want to find its mass, what particles tell you a mass? Protons and neutrons. What are the protons and the neutrons on this question? Its protons are what? Where's pencil this is? 18. And its neutrons are what? What do you do with that 18 and that 21? You add. 18 plus 21 is what? 39. That's how I got 39. I never looked at the periodic table. Okay? What else?
I mean, I just got oh, but I kind of got confused with 7.
All right, so when I look up this element, I see its mass is 64 and its protons are 30, right? So its protons are 30, so how many electrons do I have? 30. So I know those two have to be equal, right? So to find neutrons, what do I do? So 30 minus 64 is 34. So when I need its atomic number, what do I know about protons and the atomic number? They're the same. Right? All right, so let's say for a moment that well, it's not my original. I doubt Ryan or any of these other absent people, Rosa, y'all keep telling me it's moved. I'm taking her copy. All right, so if I take one, like let's just say that I take nickel, okay? Nickel only has neutrons, right? That's all I got. So what's the only thing? It's the only thing I can look up on nickel. The atomic number. I'm not looking anything else up but the atomic number for nickel. So if I look up nickel's atomic number, it's 28. I'm not looking up anything else on that periodic table. All right? I don't need anything but its atomic number. Now, once I have that, how on earth am I going to find its mass? I'm not going to look it up. I'm not going to round it. I'm not going to anything. What makes up the mass number when I need to find an atomic mass? Mass is the protons and the what? Neutrons. So what are my protons? 28 plus, what are my neutrons? 30, so I get 58. I don't round based on what's on the periodic table. I get 28 plus 30, and that's how I get 58. I never look up the atomic mass. I'm not rounding. Okay? So, if my atomic number is 28, how many protons do I have? How many electrons do I have? 28. And my symbol for nickel is Ni. Now, some of you may have done this wrong. I don't know. But when you write a two-symbol element, the first letter is always a what? And the second letter is always what? If you write a capital and a capital, I will take off. I'll actually just learn it wrong. Okay? We'll spend more time with that when we do naming. Questions about how that works? All right, so same thing when we do fluorine. All right, fluorine has 10 what? Neutrons. So, again, I have nothing here. So what's its atomic number? I look up its atomic number. Fluorine's atomic number is what up there? 9. I write its atomic number of 9 down. How many protons does it have? 9. Its electrons are 9. I'm not looking up its mass. I don't care what its mass is on the periodic table. It's an average. How do I find its mass number? What two things make up its mass? Protons and, so 9 plus 10 is 19. Everybody see how I did that? Okay. Yes? All right, let's talk about what an isotope actually is. Because you will see this word. You will see it on the exam. I'll be stunned speechless if you don't. All right, an isotope can be defined one of two ways. It will always tell you it's an element with the same something. Now, it can give you the same one of two ways. You with me, Destiny? Yo, I'm awake. Come on, wake up back there. With the same number of protons, but it doesn't have to. What did we learn the same number of protons was called on Thursday? What's the definition for the same number of protons? It was a vocabulary word. Something, something. There you go. And I'll come back and put it in a different color. And I'll do it right now. So you can have the same atomic number and a different number of neutrons. Well, in order to have a different number of neutrons, what would have to be different? What would have to be different? The atomic mass. Okay? It depends on who's writing the definition as to which way they say it. They could say that you have the same number in a different mass, or they could say that you have the same protons and different neutrons. It doesn't matter which way they say it, it means the same thing. All right? But they're called isotopes. Now, there are lots of elements that have isotopes on the periodic table. I'm going to give you an easy one that you can relate to. Everybody caught up? All right, so let's say that we take carbon. Most of you are familiar with carbon 12 and carbon 14. This is Ms. Wall's personal pet peeve. You're going to hear me say it so many times, you're going to get sick of it over the semester. Carbon 12 is called graphite. Carbon 14 is radioactive, and it's used for fossil dating. Now, roughly 99% of all the carbon found on the planet is carbon 12. It's graphite. How many of you are writing with pencils right now? Raise your hands if you're writing with a pencil. If you're writing, that's most of you in the room, not everybody, but a lot of you. All right, you're writing with graphite. You're writing with carbon. So when you turn around and ask somebody for some lead, people, lead was taken out of pencils in the early 70s. You don't have lead in pencils, okay? Hadn't been in pencils since probably, when were your parents born?
1960.
I was born in 69, and I'm 47 years old. So unless your parents are older than I am, lead has not been in pencils since before they were born, okay? So that myth that lead is in pencils has been perpetuated since probably your grandparents wrote with pencils in school, okay? Because they told your parents you had lead in pencils, and your parents told you you had lead in pencils. Lead has not been in a pencil since the early 70s, okay? See this little rock I still have on my desk if nobody stole it. People like to play with it. This lovely little rock over here. This is graphite. It's carbon. It's the same thing that's in your pencils, okay? Did it write on your paper? I know, you can erase it. It's just carbon. Now, we don't have lead in pencils because lead is toxic. If I got pissed at Trent and whacked him with my pencil, because, you know, I'm a 5-year-old in kindergarten class, and I jabbed him because he made me mad. All right, and my lead point broke off in my pencil in his shoulder. I could cause him to have lead poisoning in kindergarten. That would be a terrible thing, right? So some genius back in the late 60s and early 70s decided, oh, we better take some lead out of some pencils. So, do we still have lead in pencils? No. We took lead out of paint too, because we figured out, oh, crap, little kids are eating paint chips. Lead kills brain cells, okay? So when you turn around to your friend and go, hey, you got some lead from a pencil? Ms. Wall's going to tell you what? It's not lead, it's graphite. All right? My own children even go, Mom, we know it's not lead, but you got some lead I can borrow from my pencils? They refuse to call it lead or graphite too. All right, but it's not lead. Now, which of those two masses are we going to put on the periodic table? There's only enough space for how many masses up there? Only enough space for one. Which one are we putting up there? The 12 or the 14? Why? That's right. If you look here, most of the most of the carbon on the planet is graphite. 99% of all the carbon on the planet is graphite, so it has a bigger percentage. It's sort of like when we average your grades, okay? If you do really well on tests, it has a bigger percentage average in your grade. Your grade looks really good. Those of you who suck at tests, it's a bigger percentage of your grade. Your grade don't look so hot, right? So on your report card, your average is based on the biggest percentage. So when you do great on tests, your report card grade looks good. Same thing for the periodic table. When we look at our two different isotopes, whichever one has a bigger percentage, that's the one that goes on the periodic table. So the number that's on the periodic table is a what? It's a who? It's an average. Okay? So when you're doing the little worksheet and you're trying to find the atomic mass, do you just round the number up to whatever's on the periodic table? No, that's an average. Okay? You have to add what two particles together to get the atomic mass on the sheet? Protons and neutrons. Everybody good on that? Fabulous. Now, the second thing we want to do today, because I'm down to 17 minutes. We get out at 10:20.
I hate that. Like, days.
Second period's always shorter on the early dismissal days because it's longer on every other day. All right, is ions. All right. Now, ions work just like everything else we've done, except one tiny little thing. Now, ions are atoms with a charge. I'm going to give you 2 vocabulary words that later in the semester, you're going to swear up and down, I never taught. All right, one is called a cation. A cation is a positive ion. An anion is a negative ion. So, as an example, a cation would be like Na with a +1, and an anion would be like an O with a -2. All right, caught up? So we want to be able to find the protons, neutrons, and electrons for an atom and an ion. But
So, why are there like, so the symbols they have, why didn't they have the symbols section? Like, you know how they have different symbols, why don't they have the same?
what do you mean why don't we have the same symbol? Like why is Na and not SO?
You know, like, yeah, so.
Because they use the Latin names. I don't know what sodium's Latin name is, but like iron is ferrum, Ferrum, so Fe are the first 2 letters of its Latin name, which is why it's Fe and not IR. Or like copper is cuprum, Cu, so we use Cu. Silver is argentum, so we use Ag. So, but I don't speak Latin, so I don't know a couple. All right, everybody caught up with me now? All right, so let's say that we want to do the same thing we just did, only we're going to do iron. All right, it has a 56, a 26, and we're going to use the +3 oxidation number. All right, we want to do the same thing we did Friday. What's the only difference between Friday and right now? Got a +3, okay? Now, this +3 right here, all right, first of all, we're going to learn how to use this on, what's today, Monday? We're going to do mole calculations tomorrow, probably on Wednesday, all right? This is called an oxidation number, all right? It tells number of electrons lost or gained. All right, and because it's positive, we know it's called what? It's called a cation. Very good. All right, it's called a cation. Yep. Now, huh? Yeah, he waved through the window. I just waved back. You notice how I didn't stop. Now, what does the +3 mean? Does it mean we gained electrons or does it mean we lost electrons? Most people think that, okay? This +3, the plus sign means that we lost electrons. Okay? Anytime it has a plus sign, it means that you lost electrons. And we're going to talk about why. All right? So that means a minus sign means that you gained electrons. Did he say what he was doing now? Yours printed that way too?
No, that's.
Oh, okay. Yeah, Thornhill printed that way too, but hers is from Carolina or something, printed that way.
No, I didn't.
Okay. All right. So, how will we find the numbers of protons? How did we do that just a second ago? And on Thursday, what did we do to find protons? Somebody tell me. All right, the atomic number. So what is my atomic number, Dylan? Exactly. So there's 26 protons. All right. How did I find my electrons on Thursday, Eric? No, you didn't. How'd you find the protons on Thursday?
Atomic number.
Okay. So it was the same as atomic number, or I'm just going to write protons. Let's write. Same as the protons. All right. So that meant we had how many? All right. Here's the new piece. Now, the electrons do what? Have to factor in that plus or minus 3 or whatever number's up there, right? So that plus sign means what? You lost 3. So we lost 3 electrons means that we do what? Subtract 3. So I end up with how many electrons? 23 electrons. Now, does that change anything with the neutrons? No. All right, so when I get to neutrons, how did I find my neutrons on Thursday? Destiny, you remember? You're going to tell me you don't remember either. It was 3 days ago. I got you. How do we find the neutrons on Thursday? Sarah, you want to help her out? She's having a senior moment. We did. There we go. All right, so we said mass minus number. So what's the mass? Say it. All I hear is the piano. Minus. All right, so 56 minus 26 is 30. So what's the only thing that plus 3 affected in what we did on Thursday? The electrons. Everything else worked the same way. It had no impact on protons. It had no impact on neutrons. It only affects the electrons. Everybody with me on that? Okay. Yes. Oh, Tevin was going. He's got me. Yep. All right. Everybody with me? Yes? All right. Can I show you one other thing? All right. Let's say that I want you to write nuclear symbol notation. Okay, I want you to write nuclear symbol notation, and I give you 16 protons, 18 electrons, and 16 neutrons. All right. Suppose I give you that. All right. How is this different from what we did on Thursday? Does that look different from what we did on Thursday, or does it look the same?
The protons and electrons are different.
There you go. Okay. You have to recognize that the protons and the electrons are different. And on Thursday, they were the same. Okay? So if the protons and the electrons are different, are we going to have an atom or an ion? It's going to be an ion. Okay? So if the protons and electrons are different, you will have and oxidation number. Okay? So when you finish writing the notation, there has to be an oxidation number when you finish doing that. That's the only thing that's different. Okay? So,
would it be -2?
can you tell me the element that we would have? I hear sulfur. How do we know it's sulfur for those people who are looking around going, I don't know how they got sulfur? All right. So they looked up here and they said that it is 16 protons. 16 protons tells us the what? Atomic number. All right. So the atomic number tells us that it is sulfur. Is everybody okay with how your classmates made that leap? Okay. So we know it's sulfur for our symbol. All right. So what's the atomic number I'm going to write down here at the bottom? 16. All right. What is the mass that I'm going to write up here at the top? All right. How do we get the 32 since Tevin's yelling 32? Protons and neutrons. So protons plus neutrons are 32. Now, to get the atomic number, sorry, not the atomic number, the oxidation number. All right. What do I do to get the oxidation number? All right, so protons have 16, electrons have 18, so your classmates have subtracted and got 2, right? Now, what do you have more of? Do you have more positives or do you have more negatives? That's how they get the negative sign. Everybody good? Yay or nay? Yay? All right, because I've got about 4 minutes, assuming they ring the bell at the right place. Now, for homework tonight. I want you to finish the front side of this because I think we need a little more practice. And I want you to do the second worksheet I'm going to give you, which is on ions. All right. You will most likely see a quiz on this tomorrow. There's one with that's made over. Dylan, see if we can keep this trend going. I like that today. That's fabulous. This right here should
Oh, yeah. Did your mom not really drive?
All right, did I get all my calculators back in the tub? No, I don't have them all in the tub. Get them in the tub for me.